guys, welcome to section 6.2, which we're going to be talking about the normal model. Remember, before you start working on this, what you're going to need to do is make sure that you have StatCrunch open. You don't need any data in here, we're not going to be putting any in. And also make sure that you have the Z table that has standard normal probabilities on there. Okay, so once you have those open, let's talk about what a normal model is. Okay. So what a normal model is it's going to be any model that's going to follow a normal curve. Okay, so what that means is it's going to be unimodal and it's going to be symmetric. So all of these are examples of normal curves. Now, since these are unimodal and symmetric, that means that we're going to be using our old friends, my favorite, the two most important things in statistics. We're going to be using the mean and the standard deviation to describe our data. Now, really quick, when we're talking about probability distributions, okay, so the probability that we see something, we're going to use a little bit different language. You can almost think of them as interchangeable. So when we're talking about the mean of a probability distribution, we're going to be using mu. And when we talk about the standard deviation, we're going to be using sigma. So if we were to draw a normal curve, okay, we usually put x bar here, and then we say x bar plus the standard deviation, x bar plus 2 standard deviations, x bar minus standard deviation, and x bar minus 2 standard deviations. Okay? The same way of saying that when we're specifically looking at a probability distribution, meaning that we're using technology to draw a curve and things like that. We're not using actual raw data like we have above. Instead, you might see something mu plus sigma, mu plus 2 sigma, mu minus sigma, and mu minus 2 sigma. The only reason that we use different notation is so that the reader or whoever's looking at our data knows that we don't have raw data. We use a computer system to create it for us. So what this is going to implement, since we're looking at symmetric data using the mean and standard deviation, is we're going to be using the empirical rule. So for example, some research has shown that the mean length of a newborn seal is 29.5 inches with a standard deviation of 1.2. Alright, so if we assume that the distribution of these seals follows a normal model, we want to know what is the probability that a randomly selected seal is within 2 standard deviations. So, if we use the empirical rule, well, we know that 95% of our data, or 95% of seals, are going to fall within those 2 standard deviations. So, if 95% of them fall within 2 standard deviations, the probability that we randomly select one that's within that range is going to be 95%. Now that's really cool when you have nice numbers like 1 standard deviation, but what if we wanted to know something else, like, hey, what's the probability a seal is between 25 to 35 inches? Right? That's not going to give us a nice unit of standard deviation. It's also not going to give us a nice probability of 68 or 95%. So what we are going to use instead is we are going to standardize things first off into a z-score. Now, here's why, is because the z-score doesn't tell us inches or units like that. It's going to use the universal statistical language of how many standard deviations from the mean our observation is. So if we think of this, what is the z-score of the mean? So what that's asking is how many standard deviations from the mean is the mean? Well, the mean is the mean, so it's 0. That would be 0 away from itself. What is the z-score for our standard deviation? Well, the standard deviation would be 1 standard deviation away from the mean, so it would have a z-score of 1. So when we change all of our observations And do z-scores and standardize them using statistics, what we've done is we've created a normal model. We've standardized everything. Now when we do this, we rewrite it, and we rewrite it as n of 0, 1. Now, here's what this information means. N is going to tell you that you have a normal model. Your mean is the first number, and your standard deviation is the second number. So, to find probabilities, what we're going to use now is we're going to use something called a z-score table, okay? And that's going to give us the percentile that our data falls into. You can find this in Appendix A of your textbook, or you can just download the one that I provided for you on the website. So, here's how we are going to use this z-score table. Okay? So, first, we are going to be looking at the height of women, described as n of 64, 3, and we have a woman who is 67.5 inches tall. So first off, what do the 64 and the 3 represent? That represents an average, so you can think of this as an x-bar, equal to 64, and a standard deviation, which you can think of as SD, of 3. Now, if we write this as a standard normal distribution, here's how we're going to write that down. Okay? Remember, we're changing all of our observations into z-scores. So, what happens is that n of 64, 3, and our observation, x, equals 67.5, we're going to change those into z-scores. So remember, the mean is always going to have a z-score of 0 because it's 0 away from itself. The standard deviation is always going to have a z-score of 1. And when we find the z-score of our observation, which would be, remember, your observation minus the mean divided by the standard deviation. So z is going to be 1.1, I'm going to round mine up to 7. So the next thing that we're going to do is we're going to draw the normal curve and show where this woman would fall. So what we get when we rewrite as a normal distribution is we go from saying, oh, we have a normal curve of 64, 3, and our observation is 67.5. What we do is that we change everything into a z-score. So the mean is 0 away from itself, so z-score 0. Our standard deviation is 1 away from the mean, so that's 1. And then we take our observation, we change it into a z-score. So if we draw this curve, okay, and we include this information, here's what we're going to get. Remember, we're going to have 64, and then 3 away would be 67, and 3 more would be 70, 61, and 58. Okay, now this is writing it using the information we were given. Okay, so that's actually using the raw data. If we write it, well, I'll do it in a different color. If we write it in standard normal form, well, this would be 0, this would be 1, and this would be 2. This would be -1, and this would be -2. Because remember, the standard normal is telling you what the z-score is, or how many standard deviations away from the mean our observations are. So a woman who is 67.5 inches tall would fall about here, which, if we look at the standard normal curve, she would fall in the same place because they have the exact same shape. They're both going to be unimodal. They're both going to capture 68% of the data within 1 and 95 within 2 standard deviations. Okay. Now what we want to do is that we want to use this above information to find the probability that a woman is shorter than her. So before we do this, I always just kind of like to draw a normal curve. Okay, and then kind of roughly draw where that lady's going to be, so 67.5, And we want to find the probability that somebody is shorter than her. So all these women to the left, okay, we want to find out what percentage of women are shorter than her. So here's how we're going to do that. We're going to go to our z-score table, and we're going to find this woman's z-score. So first off, notice that if we look at the top of this page and the top of the next page, it only shows data to the left-hand side. So we can only use this table when it's talking about when somebody is shorter or less than. So we can only use this if we're looking at the probability that x is less than or equal to some value. That's not a big deal, because if we're looking at the probability that x is greater than or equal to some value, then we're going to be looking at the area to the right. And I'll show you guys how to do that in just a second. So backing up, if we want to find the probability that a woman is shorter than her, what we are going to do is less than 67.5, is we're going to find her z-score. So that's the same as finding if the z-score is smaller than 1.17. So we're going to find 1.17 on this table. So let's see, all those are negative z-scores. We want to find positive z-scores. So here's how this is going to work. We are going to find 1.1, and then we are going to look at the top, which says 0 or 0.07. And if you take 1.1 and add 0.07 to it, then what you're going to get is you are going to get 1.17. So if you line those up, that's going to give you that probability right there. So what you do is that you find the whole number and the tenths digit, then you find the hundredths digit, and then you find where they intersect on the chart, and that's going to give you your probability. So remember, these numbers here in the rows and columns are going to be your z-score, but then the numbers in the center are probabilities. So our probability that somebody is shorter than her is going to be 0.8790. Which is 87.9%. Now the next question is, what's the probability that a woman is taller than her? So again, if I draw this out, now I'm looking for the probability that somebody's taller than her. So we're looking for people that are to the right. Now what I want you guys to notice is if I took all the women that are shorter than her and all the women that are taller than her and I added them together, I would get all women. So what that means is that this is the complement of this. That means if I add them together, I get 100. So if I want to find the probability that somebody is taller than our woman, who is 67.5, by the way, you could do equals to, it doesn't matter. Well, that is going to be the same as taking 1 or 100 and subtracting that 87.9%. So what that would give us is that would give us 0.121 or 12.1%. Because again, we found this to be 87.9%. And remember, this whole area under this curve has to add up to 100, so that's going to be 12.1%. Great. Now, if we want to find the probability that a woman is between 61 inches and 63 inches tall, well, that's going to take just a little bit extra work, so here's how we're going to do that. So first what we're going to do, so let's see, 64 is right here. First what we're going to do is we're going to find the probability that somebody is 61 inches or shorter. Okay? So in order to do that, the first step is always finding the z-score. So that's going to be 61 minus 64 divided by 3. So that's going to give us a z-score of -1. So the probability that somebody is 61 or shorter, so let's find -1 in our z-score table. So let's see, -1, that's going to be right here. So that's going to be 0.1587. So this right here is going to be 0.1587 or 15.87%. Now let's find the probability that somebody is 63 inches or shorter. And let's go ahead and do that in a different color. Let's do that in yellow. Okay, so if I find the probability that somebody is 63 inches or shorter, again, the first step is always finding the z-score. Okay, and that's going to be -0.33. So the probability that somebody is 63 or shorter. So now we're going to find that -0.33 z-score in our table. So let's see, -0.3, and then I have 3 here, so if I line those up, I'm going to get 0.3707. So what that tells me is that the probability that somebody is 63 or shorter is going to be 37.07%. Now here's the deal. I want to find this probability in between these two. So since I want to find the probability between these two, what I'm going to do is I'm going to take the larger percentage minus the smaller percentage. That's going to give me this area in between them. So the probability that somebody is 61 to 63 inches tall is going to be 0.3707 minus 0.1587, which is going to give me 0.212 or 21.2%. Great, so when you're doing this by hand, remember, find the z-score first and then find that z-score in the table. Another easier way that you can do this is using StatCrunch. So using StatCrunch, here's how you do it. You're going to go to Stat, Calculators, and then we're going to go to Normal since this is a normal distribution. Now, when we do that, here's all the information you need, is we're going to change the mean to 64 and the standard deviation to 3. Now, let's say that we want to know the probability that somebody is 67.5 inches or shorter. We hit compute, and then it's going to give us that probability right here. If we want to look at the probability that they're taller, we're just going to change it in equality sign, and that will show up right here. Now notice that our numbers are slightly off. That's because we used an approximation using our table. This is a little bit more exact. Now if you want to find probabilities for in between, you're going to go up to this left-hand corner and just hit between. And let's say we want to find the probability that somebody's between 61 and 63. Well, then there you go, 0.21, which if we look back at our answer, pretty close. So that is how you do that using StatCrunch. When you're doing the homework, I suggest you do it using this. However, it is good to know where these formulas come from. So either way. All right, I think that's long enough. We're going to go ahead and turn this into a second video. Remember, on the second video, also have StatCrunch and your z-table open.